Okay, so we will now just look at the corrections for the test on exponents. And the test is basically a recap on everything you need to know on exponents. So we've got law 1 to 4, multiply the same base, add the exponents. When you divide the same base, you subtract the exponents. When you have a power to a power, you multiply the exponents. And then when you have more than one basis, even if it's a number, the exponent needs to go to all of those bases. Right, and then how to treat negative bases, and then exponents equal to 0, so anything to the power of 0 is 1, and then mixed operations, so just basically questions that have all of these together that you need to solve. Okay, so question 1 is this. Now, the first thing I've noticed a lot of people do is when they have 2 to the power 4 and 2 to the power 1, they tend to multiply the 2's as well. But you need to remember just to treat like the base or the number, even if it's a number, just treat it as the same base and just go ahead with following the exponential law. And here we'll just say, okay, this is 2, 4 plus 1 multiplied, and I'm just using a dot for multiply when I'm working with exponents because it's simpler. And then 5, 3 plus 7. Okay, and then we just basically get 2 to the power 5 times 5 to the power of 10. And this step right here is not really necessary, but I'm just doing it to show you basically what happens. Now, this is the method where we just follow the exponential laws. But something that I find easy, that you'd never forget that you have to add them, is just to think about 2 to the power 4 is like 4 2's right next to each other, times with each other. And then if you times that with another 2, if you group these together, then you're going to get like 5 2's next to each other. Obviously, just make sure there's dots, otherwise it looks like a larger number. But this is then 5. So if you think about 2 to the power 4 as 4 2's next to each other, and this is just 1 2, if you put them together, then there'd obviously be 5 2's next to each other. For me, that's how I think about it when I do these sums. All right, now for 1.2, now let's start by simplifying basically the brackets. It's always useful to like apply BODMAS in these scenarios. So let's just rewrite 3a to the power of 9 times. Now here minus and minus becomes a plus. 2 times 1 is just 2, and then b, so 6 plus 3 is 9, and then we have to multiply these two together. So this is going to be 3 times 2, which is 6. And remember to just treat your coefficients as normal numbers. And then a to the power of 9 times b to the power of 9. Now, these two are different variables. So this is just going to be a to the power of 9 and b to the power of 9. Then we just write it like that. Okay, 1.3. Now, in this case, you have to distinguish between this, where we've got 4x to the power of 0, and here we have 4x to the power of 0, where this is only the x, the base of x is to the power of 0, and here the entire thing is to the power of 0. So in this case, this 4 stays 4, and then you'll just replace x to the power of 0 with 1, and then times by now all of this inside the bracket. The 0 applies to all of them, so that entire thing becomes 1. So we have 4 times 1 times 1, which is just 4. Okay, and then question 1.4. So here we have to multiply in the base to multiply the exponent or the power into each and every base. Okay, now be careful, this happens so many times. This is not 8 squared. Okay, this is 8 to the power of 2. Okay, so we've got 8 to the power of 2, then x 3. Okay, let me put these steps in. 3 times 2, and then y to the power of 2. So 8 to the power of 2 is 64. And then we've got x to the power of 6, y to the power of 2. Now, a lot of people know this is 8 to the power of 2, but it is very easy to make that mistake, that silly mistake of just saying 8 to the power of 2, 8 times 2, and then write 16. 1.5. Again, same scenario. So we're going to take this into each and every one. So I'm not going to write the intermediate step. I'm just going to calculate that, which is fine. 3 to the power 3 is 27. And then 8 to the power 4 times by 12. 4 times by 3 is 12. And then B, 8 times by 3 is 24. Okay, in this case, we are focusing on negative bases. Now, what I've said is that if your exponent is even, your base is going to become positive. So if I have -1 times -1, these two ones basically cancel each other, or they merge together and become a positive, because two negatives become a positive. So this will just be +1. But the moment I have an uneven amount of negatives times with each other, then it's going to result in a negative again, because these two become positive, then you're left with that negative. So if you have that, this is going to become a positive because it's got an even exponent. So this is +1, or 1, and then times by, and this one is an uneven exponent, so this is going to remain -1. So 1 times by -1 gives you a -1, because a positive and a negative becomes a negative. Right, so question 1.7. Now in this case we've got -2 to the power 3, and here we have a negative or uneven amount, uneven exponent. So in normal case this would be 8. So this is now going to stay -8, and then times by -2 to the power 4. So here this is going to become a positive. So 2 to the power 4 is 16. So because this is even, it's still going to remain a positive 16. And then we just need to multiply 8 by 16. All right, so now since we don't have calculators, let's just work it out with long multiplication, which you actually also need to know for the test. So 6 times 8 is 48. And then 8 times 1 is 8, plus 4 is 12. So this is just 128, but with a negative times a positive, it becomes -128. Okay, then for question 1.8, so here, when you have a negative value inside this, inside a bracket that's to the power of something. Now, just basically treat this as one number, as -5. Then when you square that, because it's squared, it's going to become positive. So that's just going to become 25. And then p to the power 4, q to the power of 8, when we multiply 2 times 2 and 4 times 2. Question 1.9. Now again, let's say that is -5 and then to the power of 3. So 5 to the power 3 is 125. But this is now going to be, this is going to stay a negative because of the uneven exponent. So -125. And then p, 2 times 3 is 6. And q, 4 times 3 is 12. 1.10. Okay, in this case, be careful. This is another common error. Whenever we have like a bracket to the power of whatever's in front of the bracket, you can't multiply it in yet. You have to apply the power, or the square, or the root, or whatever power. So let that negative just hang around for a while. So then this -2 to the power of 3, that's going to become -8, and then x to the power of 3, y to the power of 15, and then this now only, whatever is here, even if it's a number, just now we can multiply it with what's inside the bracket. Now minus and minus just becomes positive, so this just becomes 8, x to the power of 3, y to the power of 15. For 11, again, don't make the mistake to multiply the minus in. Okay, so there's the minus, and then this -2 to the power of 4 is going to become positive 16, and then we have x to the power of 4, y to the power of 20, and that just simplifies to -16, x to the power of 4, y to the power of 20. Okay, now for this one, it's possible to basically take the 3 in directly, but it's easier to first just simplify this inside. Okay, that makes It makes the work a lot less. So the minus is still there. And then if we just simplify the inside first, we've got minus 3 times 3, which is minus 9. And then we have a to the power 3 times a to the power 3. So this will be 3 plus 3, the 3 a's together. So basically, then you just do this. Obviously, if you want to think about it that way, so then this is in total 6 a's. And then to the power 3. So now we've got the negative, and then here we have negative 9 to the power 3. So I know it's 81 times by another 9, right? Because 9 to the power 3 is basically 9 times 9 times 9, and this becomes 81. So 81 times by 9, so that's 9, and 9 times 8 is 72. So this should be 729. So this is, and it's going to stay negative because of the uneven exponent. So negative 729, and then a, so 6 times 3, that gives us 18. Okay, and then minus and minus becomes a positive, so we have 729 a to the power of 18. Question 2, so for 2.1, again, just treat the 3's as normal bases, but now we are dividing. So this means we've got 3 and we minus the exponent. So 8 minus 5, and then we get 3 to the power of 3, and this we can simplify to 27. And again, what would be another way of thinking about this is just going straight forward into the exponential laws, but there's 8 3's next to each other. Let's just draw them like that, over 5 3's. That is one too many, so let's just erase that. Okay, so now obviously times together. So now when we cancel 5 here with 5 at the top, and we are basically left with that 3. So that's where that 3 actually comes and why this law applies. Right, now next one, question 2.2. Again, we've got 4 to the power of 2 and 4 to the power of 3. So if we just apply the law as it is, and this is actually why I showed you the previous method, we've got 4 and then 2 minus 3, but now we end up with 4 to the power of negative 1. So this, if we have a negative exponent, basically what we do is, let's put this over 1, we can take the base down. We can literally take it up or down, but we take the base down and we change this to a positive. So this is going to become 1 over 4 just to the power of 1. So this is just 1 over 4. Okay, just another quick example. Let's say we had 1 over x to the power of negative 7 at the bottom somehow. In order to make that a positive, we take the base up and we change that into a positive. So this will just be x to the power of 7. Okay, now in this case, it's definitely easier to think about there's 2 4's next to each other, and there's 3 4's next to each other. So these two cancel these two, and you're left with 1 in the denominator. So this is going to be 1 over 4. If everything cancels, either in the numerator or denominator is not just 0, you're going to just put a 1 as a placeholder. And then that's your final answer. So question 2.3, this is again actually easier to do just with your exponential laws, where x 14 minus 8, and then we get x to the power of 6, x to the power of 6. And then for 2.4, so here the 2's are just a normal fraction. So if I basically have 2 over minus 2, these two cancel, and you're left with minus 1, basically, or 1 over minus 1. But yeah, that's just minus 1. So in this case, this part over here just simplifies to minus 1. So that So those two cancel. Then we can just write the minus there. If you have a fraction, you can write the minus, like let's say a over b. You can write it there. You can write it a over b. You can minus a over b. You can write it as a over minus b. All of these are basically the same. The minus can basically float around. So then here, y to the power of 8 and y to the power of 15. In this case, because the bigger one is at the top, I'm just going to think about y 8y's cancelling with 8y's at the bottom. Like you can even think about, okay, if you're going to split this up into y to the power of 8 times y to the power of 7, because when you multiply the same bases, you get back to that. Then this and this will cancel, and then you'll be left with that y to the power of 7 in the denominator. Okay, so this is going to be 1 negative 1 over y to the power of 7. That's one method. Obviously, if you just use your exponential laws, you'll have negative y8 minus 15, and this will give you negative y to the power of negative 7, and then to change that negative exponent into a positive one, we just take the y into the denominator. So this is minus 1 over y to the power of 7. Question 2.5. So here the minus is there. So that's the only minus. So we can just, if there's just a minus, just put it down there. Like it's just going to stay. If there's two minuses, then obviously they're just going to group together and become like a positive. So this is going to be 2 to the power of 3, because we've got 7 minus 4. We've got, either way you want to think about it, but it's going to be 2 to the power of 3, and then times by 3 to the power of 4. Okay, now these are things that we can simplify without a calculator. So this is just going to be negative, that's 8 times by 81. Okay, so again, let's just do the long multiplication. This is 8, and then 8 times 8 is 64. So this is going to be negative 648. And then question 2.6. Now in this case, again, we've just got the exponents in the denominator is bigger in this case. So 3 3's at the top, 5 3's at the bottom. So if 3 cancels with 3 at the bottom, then you'll be left with, so let's just put a placeholder 1 for now. Then you'll be left with 3 squared. And then if you have 9 fours at the top and 10 fours at the bottom, you'll be left with 1 at the bottom. Okay, and again, we can say, okay, this is 1 over 9 times by 4, or times by 4, and that gives us 36. So 1 over 36. Now for question 3, so 3.1. In this case, treat the negative, and the negative will become a positive, okay? And treat the 24 over 12 as a normal fraction. So to simplify that, this is just positive, and then 12 can go into itself once, and it goes into 24 2 times. So here we'll have a 2, and then there's a x to the power of 10. So that's going to be an x to the power of 5. So this is going to be x to the power of 5 in the numerator, because we've got 10 minus 5, which just becomes 5. Now, in this case, we've got 16 at the top and 18 at the bottom. So if 16 cancels at the top with 16 at the bottom, you'll be left with y squared. There's going to be 2 y's left in the denominator. So we'll just put this over y squared. Okay, now here, we want to simplify like the numerator first, then the denominator, and then simplify the fraction as a whole. Now here we've got 12 times 4, which is 48. So it's negative 48, because 12 times negative 4, so it's negative 48. And then a to the power of 4 times 8 to the power of 1 gives us a to the power of 5. And then b squared, b times b squared, over And again, this minus must just stay there for now. And then this is going to be 2 to the power of 4, which is 16. And then a to the power of 12, because it's 3 times 4. And then b to the power of 16, because it's 4 times 4. Okay, so these negatives can cancel. They become positive. And 16 goes into 48 3 times. So this is going to be just a positive 3 there. And now here, both of these variables are, the exponents are bigger. So this is going to be over. Now 5 at the top cancel with 5 at the bottom. We're left with a to the power of 7. And then 2 cancel with 2 at the bottom. So this is going to be b to the power of 14. Okay, and then 3.3. Now again, let's simplify the inside first before we take the 6 in. And on the inside, we can simplify the numerator on its own. We can simplify the denominator on its own. So this is basically just like three small sums in a big one. Like this is very easy. We know that 4 times 8 is 32. So this is 32, a to the power of 6. And then here, 2 to the power of 4 is 16, a to the power of 4. Okay, now inside, still on the inside, 16 can go into 32 2 times, and then a to the power of 6, a to the power of 4, 6 minus 4, that gives us a to the power of 2, all to the power of 6, and then this goes 2 to the power of 6. So 2 to the power of 6 is not that obvious, but it is, for example, 2 to the power of 5 is 32, so 2 to the power of 6 is just double that, which is 64, and then a 2 times 6 gives us 12. Okay, and then 3.4, again, let's simplify the inside. So this has to go first. This is like the square. And then also we can multiply, in this case, we can multiply the 5 into the bracket because there's nothing here. There's no power there. Okay, so that's what we're going to do first. This is just negative m squared, and then this becomes 25 m to the power of 2, and that's over negative 25 m to the power of 3. So this is all still to the power of 2. Okay, next we can just multiply these two together. This is negative 1 times 25 is negative 25, then m to the power of 4, because it's that plus that, over negative 25 m to the power of 3, all squared. And this is then going to cancel, these two cancels, m to the power of 4, m to the power of 3. So this is just going to become m, 4 minus 3, or 3 cancelling top and bottom, and that is just then going to be m squared. Okay, last one. So here we're going to multiply this and multiply this. That's pretty simple. Negative 2 times 9 is negative 18, and then x to the power of 10, 4 times 6, over, so negative 6 times 3 is also negative 18, and x to the power of 1 times by x to the power of 5 is x to the power of 6, and that's all to the power of 5. And then we've got these two that cancel, and that's going to be x to the power of 4, 10 minus 6, and that is to the power of 5. So now we've got x to the power of 4 times by, so 4 times by 5 is x to the power of 20.